In this lesson, we are going to look at the mathematics of direction, which is known as bearing. So what is bearing? A bearing is a direction traveled between 2 points and is given as an angle in degrees. A bearing is the direction traveled between 2 points and is given as an angle in degrees. So if a man starts at this position and then he went this way, this is known as the bearing. The angle turned, the direction traveled is known as the bearing. So when this angle is noted, if it's 50 degrees, this is north and then this is east. So this will be the man traveled in the direction not 50 degrees east. So that's the bearing. So if a plane flew from a place, let's say point A to point A, if you mark it with your cardinal points, and then okay, let's say plane flew from point A, you mark your cardinal points, and then come this way, then you have this point to point B. The bearing of the bearing of the plane from where it started the journey, which is point A. This is the final destination. So the bearing of the plane at the final destination from the initial, from the starting point is not, let's say if here is 140 degrees, as the bearing of the plane at its final position or final point from the initial point is 140 degrees. So you see that here is not 50 degrees east and here is 140 degrees. So this and this are not really the same. This is 3-digit bearing and this is compass bearing, the two types of bearing we have. So we're going to treat each one of them, but I just using this to illustrate as a result of the definition that has been given for bearing. So a bearing is the direction traveled. Anytime we're talking about bearing, bearing has to do with direction. So bearing, I term it as the mathematics of direction. So a bearing is a direction traveled between 2 points and is given as an angle in degrees. So who uses bearing? Pilots in the air, sailors at sea, and surveyors use bearings to find directions. Any given bearing angle is represented in two ways, namely compass bearing, which is also known as cardinal points, or 3-digit bearing, which is also known as the surveyor's bearing. All right. So the compass bearing, the 3-digit bearing, these are the two main types of bearing, or the two types of bearing rather, and we are going to look at each of them particularly. So let's move to the first one, the compass bearing. Compass bearing is also known as cardinal points or cardinal bearing because it is basically based on the compass, the notations on the compass. So the compass is used to get the directions. So this concept is based on cardinal points as can be obtained in any standard compass, such as shown below. So the compass bearing is based on cardinal points that can be obtained in any standard compass. A compass is an instrument that is used to gauge or determine the direction of an object. So people who travel in maps or who go for adventures, they always carry the compass so that wherever they are, they could get to find their way. So because the compass helps to give direction, it helps navigation easy. Sailors, pilots, they all make use of the compass bearing, or they make use of bearing generally. So the compass bearing or the cardinal points, this concept is based on cardinal points as can be obtained in any standard compass, such as shown below. So in a compass or cardinal points, we have a vertical line and horizontal line. So both of them intersect at this point. This is 90 degrees, this is 90 degrees, 90 degrees, 90 degrees, but there's no point. We don't need to indicate the degrees yet. So let's just leave it bare as it is. Okay. So now up the vertical line is the north pole. So we call it the north. Down the vertical line is the south. And this way is east and this way is west. So take note of these notations. We have NWSE. So north, west, south, east, or northeast, southwest. Now in between we have other lines. So between the north and the east we have the northeast, which is northeast, and between the south and the east we have southeast. Between the south and the west, southwest, and between the north and the west we have the south. So between the north and the west we have the northwest. So any direction that falls within the north and the west in compass bearing, always go with the notation northwest. So north, the bearing, then the west. As an example, north the bearing, and then the plane in which the direction falls into. This direction falls into the north and the east plane, or the north and the east quadrant of the compass. This compass, the north and the east quadrant of this compass. So the angle measured is stated as north 50 degrees east. So any direction that falls between the north and the east, always go with the notation northeast. North, then the angle or the direction or the bearing, and then east. The ones that fall between east and south, or south and east, always go with south. The south comes first. If it's between the north and the east, the north comes first. If it's between the north and the west, north comes first. And if it's between the south and the west, south comes first. That's why the notation is southwest, northwest, northeast, and southeast. So the starting points are based on north or south, which are measured to either east or west. So something that you need to take note of is that whenever the compass bearing is used, the starting point is always measured from the north or the south. So you could see that from what we have here, this direction that's between the north and the east, the first notation is the north. The one that is between the south and east, south is coming first. The one between the west and the one between the south and the west, south is coming first, and also north and west, north is coming first. So anytime angle is measured using the compass bearing, you always take your notation from either the north or the south, and that determines on which plane the direction is falling into. So for instance, if we have someone who took a walk from this point down here, you see that this line of direction, this line that indicates direction, is between the south and the east. So your measurement will start from the south pole to meet the line. So from the south pole to this line, that will not give you the degrees, the bearing. So this will not be south. So let's assume that this is 67 degrees. So this will be south, 67 degrees east. That's how we do it. So what if it was from this point down? So it's still between the south and the west. So it will start from the south to meet this line, and that will give us, and let's also say that this is 27 degrees, assuming, so this will give us south 27 degrees east. But what if it was like this? Let's say the movement was like this. So take note, for compass bearings, only either from the north to the line that indicates the movement of the object we are considering, or the movement of the object of concerning whose direction we are trying to compute or calculate, or the south. So take it either your direction taken from the north when it's between the north and the west, or north and the east, or the south when it's between the south and the west, or the south and the east. South and the east in this case, and south and the west in this case. So now north and the east. So this is northwest. So between the north and the west and this one, so this is east. So if it's the line that indicates the movement of the object and concerning whose direction we are trying to calculate, or the bearing which we want to know, if the line is here between the north and the west, then the angle that will indicate the direction or the bearing will be measured from the north to that line. So from the north to this line, so if it is 57 degrees, this will be north, 57 degrees west. And if here, then from the north pole to this line, that will give us north. So if it is 30 degrees, this will give us north 30 degrees east. So that's the basic thing you need to know about the compass bearing, or the cardinal points. The measurement is always from the north or the south. So the north to the east, or north to the west, north to west, north to east, or south to east, or south to west. That's the principle behind the compass bearing. So let's go on. The starting points are based on north or south, which are measured to either east or west. From north to east or north to west, we can only cover between 0 degrees and 90 degrees. Okay, so that's another point we need to note. From north to east. So if you are going from the north, so this is starting from the north in compass bearing. So it's assumed that the north is 0 degrees, and then the east. So you can see that between the north, which we are always starting from, or the south, which we are always starting from. If you are starting from the south and it's 0 degrees, so if you rotate from here down to this point, that's 90 degrees. The full rotation from the south to the east is 90 degrees. The full rotation from the north to the east is also 90 degrees. So remember from what we have here, this is a perpendicular. When a vertical line and a horizontal line meets at a point such that they form this angle, so that they are in this form. The angle formed between the vertical and the horizontal in this form is always 90 degrees, and that's what you are seeing here. So when you are going from the north to the east, if you go fully from the north to the east, you have covered 90 degrees. From the east to the south, or from the south to the east, 90 degrees. From the south to the west, 90 degrees. From north to the west is also 90 degrees. So all together, you have 360 degrees. So from north to east, or north to west, north to east, or north to west, we can only cover between 0 degrees and 90 degrees. The same applies to south to east. So if you're going from south to east, it's also 90 degrees, or south to west is also 90 degrees. So below are examples of compass bearing. So let's represent this compass bearing diagrammatically. So number one, let's say north 30 degrees east. We draw our diagram, north 30 degrees east. So our north pole and our south and our north, these are north and what I call north pole. We are not doing longitude and latitude yet. So this is our north, this is east, this is south, and this is west. All right, so north 30 degrees east. So if we measure a line, so the line would come like this because it's north 30 degrees east. So between the north and the east, that's where the line will fall into the plane. So fall into this plane. So measuring from the north pole to this line will give you from here is 0. So if you put your compass, your protractor rather, this is a 90 degrees. You place it here on this point. Make sure that the protractor, usually a protractor is in this form, and then you have this something like this, and this is 90 degrees. And then from here you have series of angles like this and like this, like this. So make sure this horizontal line is placed. If you're using a protractor, you want to be so accurate. You place this horizontal line on this west-east line, and then make sure this 90 degrees coincides with this north pole, this north line, which is 90 degrees. And then from there you can mark off your 30 degrees. So from the north pole to this line is 30 degrees. So how do we represent this? This becomes north 30 degrees, north 30 degrees east. So for number 2, north 15 degrees west. So north 15 degrees west. So we like this. So this is our north, this is our south, this is west, and this is east. So north 15 degrees west. From what you can see, number 2, we have north and west. So the plane or the movement would be in the northwest plane. So now from here, you measure from the north pole to meet this line, not from the north pole like this. It's no, as long as it's compass bearing, you don't measure from the north pole to meet this line here. Rather, you measure from the north pole this way, anti-clockwise direction. Okay, so you measure like this to meet the line if it's from the north to the west. Then if it's north to east, you measure clockwise in the clockwise direction to meet the line. So same way, if it's south to east, you measure in the anti-clockwise direction. But if it is south to west, you measure in the clockwise direction. Yes, clockwise direction. Yeah, correct. Okay, so north 15 degrees is same thing. If you're using a protractor, place the protractor on this line, which is this horizontal side of the protractor. Make sure it coincides perfectly with this line, and then make sure the 90 degrees line, this line also coincides perfectly with this vertical, which is the north. And then from there you can mark off the 15 degrees. 15 degrees then, so this becomes 15 degrees. So this, we can write this as north 15 degrees west, because it's between the north and the west. Okay, then number 3, south 50 degrees east. South 50 degrees east. South 50 degrees east, that indicates that the movement or the movement concerning whose bearing we are looking for is between the south and the east. So which means it's going to be in this plane. So southwest and then south. So, and what's the degree? 50 degrees east. So now because it's 50 degrees east, and the rule says in compass bearing, your bearing or your angular measurement is starting from either the north or the south. So from the south pole or from the south to this line will give you the 50 degrees. Same way, if you use your protractor, you place this part here and then you turn it over. So instead of facing this way, it's going to look like this. Yes, and then make sure this is a 90 degrees and your series of angles like this and like this. So you place this part on this spot, and then this 90 degrees must coincide with the south, and then you find where 50 degrees on the compass coincides with this line, and then that is it. You can then you draw a line to meet this mark here. Okay, so this is south 50 degrees west. That's how we represent it. Then number four, south 55 degrees west. Well, I must say at this point that if you are not using a compass to measure the angle, which most times is not necessary because this is not technical drawing and this is not low cost. So what you do right now is just know which plane the bearing is. Just understand the notation. Just for now, for bearing, just have it at the back of your mind that if it's compass bearing, your starting points are either from the north or from the south. So from the north to the east or from the north to the west, and from the south to the east or from the south to the west. That's all you need to know. So here we have south 55 degrees west. So this will be between the south and the west. So 55 should be here. So I'm not really bothered about the accuracy of the degree, whether it's perfectly 55 degrees. All I know is that I'm going to start from the south to meet this line. So I will put my 55 degrees here. So this will be south, and this is west, and this is north, and this is east. So what is this? This is south 55 degrees west. So that is it. That's how we represent compass bearing notation diagrammatically, and also from the diagram we can represent them in notation form. So now let's look at the 3-digit bearing. This type of bearing bases its starting point from the north only. Take note of this. This type of bearing, which is a 3-digit bearing, bases its starting point from the north only, then moves in a clockwise direction. The movement is between 0 degrees and 360 degrees. So what you should know is that first thing first, 3-digit bearing, according to the name, your bearing is always in 3 degrees. So you have 0, 0, 0. So if your degree is 1 degree, that will be 0, 0, 1 degrees. If it is 10, it will be 0, 1, 0 degrees. If it's 20, 0, 20 degrees. Also, maybe 257 degrees up to 360 degrees. So you're always in series. So that's why the name 3-digit bearing. Then the peculiar aspect of 3-digit bearing is that it starts from the north only. It does not involve north and south, unlike the compass bearing, where your measurement is either the north to a line or from the south to a line. But for 3-digit bearing is basically and peculiarly from the north only, So the north to wherever the movement was made. If the movement was from here, so for 3-digit bearing from the north to the line, you meet it and then you calculate. If it's here, then from the north to this line, you meet it and then calculate. If the line is here, then from the north to this line. If the line is here, then from the north to the line. That's the peculiar thing about 3-digit bearing. It's always from the north. So the movement is round the clock in anti-clockwise direction. Sorry, movement is in a clockwise direction. So from the north to wherever the line is. Then another thing you need to note is that for 3-digit bearing, the basis of the quadrant. But the quadrant that 3-digit bearing uses is peculiar also in the sense that it is different from the usual quadrant you know in trigonometry, although this is also under trigonometry. But when the 3-digit bearing uses a quadrant, its own way of using this quadrant is different from the one that we know in trigonometry. In trigonometry, the quadrant starts from 0. This is east, so it starts from here 0. So from 0 to here, which is the north, So in trigonometry, we don't even use north, south, west. We just use the quadrant as it is. So we call it the Cartesian plane. So this is x. X plus x. In your Cartesian plane, your graph, this is plus x and this is minus x, and this is minus y, this is plus y. So from here to here is 90. So this is within 0 to 90 degrees, and from here to here within 90 degrees to 180 degrees, and then from here 180 degrees to 270 degrees, and here 270 degrees to 360 degrees. So by the time a line rotates from here down to this point, it has done angle on a straight line, that's 180 degrees, and then from here down to this point, that's angle at a point, which is 360 degrees. So rotations from here to angle at a point. So that's for the quadrant. So for the quadrant, the rotation is in the anti-clockwise direction, starting from the east, which is a plus x, the positive axis, the positive horizontal axis, which is x, and is in the anti-clockwise direction like this, goes like this. But for quadrant, there's a change. So for quadrant, our 0 starts from here, which is from the north, and then this is 90 degrees. From the north to east is 90. From north to here is also 90. But from the north, from east to south is 90. But from the north to the south is 180. I'm going a straight line. That's 180 degrees. And then from the south to the east is 90. 90 plus 180 is 270. 270 degrees. And then from the west to the north is 90. But from the south to the north is 180. But from the north to the north back again, that's 360 degrees angles at a point. And for the quadrant that's used by 3-digit bearing is in the clockwise direction, because it's from the north only. The north is in the clockwise direction. So for 3-digit bearing, our measurement starts from the north. So the first quadrant, this is the first quadrant, is between the range 0 to 90 degrees. The second quadrant is between the range 90 degrees to 180 degrees. And then the third quadrant is between the range 180 degrees to 270 degrees. And the fourth quadrant is between the range 270 degrees to 360 degrees. And that means you would have gotten back to where you started from, as the north again. And so that is that. So take note of that. So in a way to summarize or encapsulate, for 3-digit bearing, your measurement starts from the north only. It starts from the north only, and it's always done in the clockwise direction. It's always done in the clockwise direction. And then it has its own peculiar quadrant, which is different from the one used in trigonometry. And it is that your first quadrant is here, your second quadrant is here, your third is here, and your fourth is here. And you should know the range of the angles, because that's what will help. For instance, if you have 0.95 degrees as your 3-digit bearing, by the time we start going to calculations, you will just know where to place this bearing. So I will just draw my compass bearing, because after this lesson, the next one, we're going to look at the relationship between compass bearing and 3-digit bearing. How we can convert from 3-digit bearing to compass bearing. So in this way, I'm going to be using my compass bearing to convert 3-digit bearing to compass bearing, and also how we can convert from compass bearing to 3-digit bearing, so that when you are solving questions on bearing, you will be required to convert from one form to another. You will not be at a loss to do that when the time comes. So for instance, when we want to represent this simply, if you are just representing this as a 3-digit bearing, then this is how it will be. You know that, like from here, like this is 90 degrees. So if it's going to be 95, then it's going to be slightly greater than this being 90 degrees. So this is how it's going to be. So from the north to this line is 0.95 degrees, the north, and then the line. So you don't usually represent it, you leave it like that. So then if you are given 125 degrees, you know that from this straight line is 180. So but 125 is less than 180. So this is from here to here, like this is 90. So 125 should be like this. So from the north to this line, that's 125 degrees. But if you are representing this in compass bearing, what do you do? In compass bearing, since we are converting from 3-digit bearing to compass bearing, so you start from the north pole to wherever you're going to have 125 degrees. This is 125 degrees. 125 degrees. This is the 3-digit bearing. Then for the value of this in compass bearing will not be from the south pole to this line. So here will not be. So of course, what you have here is now angles on a straight line. So 180 minus 125, you get your theta. So the value of theta will be 180 degrees minus 125 degrees, and you get your answer here. But we're not doing that in this lesson. That will be the next lesson. So I just want to use that as an illustration. So now let's represent these 3-digit bearings diagrammatically. So diagrammatically, number one says below. Okay, the statement says below are examples of 3-digit bearing. So 0, 10 degrees, 0, 10 degrees. 0, 10 degrees is within this first quadrant. So it's just going to be something like this: 0, 10 degrees. So from the North Pole to this line, 0, 10 degrees. The arrow indicates that the measurement was done starting from the North Pole and ended when it met this line, which indicates the direction of the line. So 0, 10 degrees. This is our 3-digit bearing, or we can write it here and say this is okay. It's okay here, 0, 10 degrees. That's it. The Roman figure 2, 0, 80 degrees is still within this range because the first quadrant is 0 degrees and 90 degrees. So it's not yet a perpendicular. So what we have, this is from the north. So we're going to have something like this. So from the North Pole to this line, okay, so this is 0, 80 degrees. And then number 3, 150 degrees. 150 degrees is slightly close to a straight line, which is an angle on a straight line, which is like this. So if this is our cardinal, so that means 150 should be something like this. So from here to here will give us 150. So that's how it's going to look like this. So from the North Pole to this line, this goes 150 degrees. And then number 4, 320 degrees. 320 degrees it's just few degrees away from getting to 360 degrees. That's a total turning point, a total turn rather. So that would look like, so from the North Pole to something like this. So from the North Pole to this line, this is 320 degrees. So if you are representing this with your compass bearing, you know that from your compass bearing, here is 0, 90, 180, 270, 360. So from here, like this. So from the North Pole down to this line, that will give you the sorry, I'm not even supposed to present. From the North Pole down to this line like this, that's how it's going to be, because the measurement is in the clockwise direction from the North Pole to the line. So this is from the North Pole to the line, from the North Pole to the line, to the North Pole. So it's going to be from behind. So that's it. This is the compass form. This is just plain. So this is 320 degrees, and still here is also 320 degrees. So this is how we represent 3-digit bearing diagrammatically. So in the next lesson, we're going to look at the relationship between 3-digit bearing and compass bearing.